Okay, so hello everybody. I would like to present RootInteractive expert tool for multidimensional statistical analysis, machine learning, and analytical model validation. So first I will show the presentation, and then I will show the Jupyter Notebook interactive tutorial or interactive demo. So the RootInteractive project started within the Alice experiment. As the Alice in the round 3 is much more complex as it was in the round 1, round 2. So we collect huge amount of the data. We have huge overlaps. We have the lot data, 50 kilohertz. It means that we have not one event, we have 5 events in the TPC. And in addition, we don't know the time. So we don't know the translations of the time within the time projection chamber to the Z coordinates. So we have to connect it with the other detectors to get back the time. In addition, there are tracking challenges. So we have the space charge in the TPC, which is distorting the trajectories. So we have huge occupancy. This occupancy charge inside of the TPC is distorting electric field. And this space charge is not only distorting, it's also fluctuating. So we have the 0.5 centimeters or 0.10 centimeters distortions, and we would like to correct it back to the 100 microns resolution. And we have to do it with the time granularity, which is corresponding to the intervals by which the things are fluctuating, which is of the level of 1 to 5 milliseconds. Additional challenge which we have is the challenge in the PID, in the particle identifications. So we have significant baseline fluctuations. So if you create the signal at some position, then first of all, this signal has a tail, so which you can see here, and the signal in one positions generate the undershoot in all other positions. So we have to correct it back. So we have to give it back. So we developed the digital signal processing algorithms which should recover it partially, because we don't have only the long range baseline bias, but we have also the short range baseline bias, which comes from the overlaps. So this high interaction rates, pile-ups, distortions demands advanced data analysis methods. So we need to prepare the experts, and it's difficult to be expert. So we need to have the highly customizable tools to navigate and interpret data in the multidimensional parametric space. So all these things has plenty of the parameters, and we have to keep track and we have to understand it. So seeing is believing, but we would like to understand. To understand, we would like to query, to iterate, predict, and confirm our understanding. So if we know to predict, if we are consistent in the multi-dimensions, then I say that we understand the things. So we want to teach or create experts. So therefore, we created the multidimensional interactive data analysis framework, this RootInteractive, which consists of the two parts, but I will focus mostly on the client-side data aggregations. So in the first part, we have some set of the wrappers on top of standard tools. And then we have the tools for the online data aggregations, which should handle something like 10 to the 6, 10 to the 7 rows, 10 to the 300 columns, up to 10 to the 8 data points directly within the browser environment. So this tools is used actively for the Alice Expert projects in the reconstruction, alignment, calibration, Monte Carlo data remapping, in the expert data representative sampling, and in the PID calibrations. And there are other things which are in to-do list. And there is also pilot projects on the particle productions as the functions of the event properties. So so now we are in transitions of moving usage of these tools from the reconstruction calibrations also to the physics analysis. So what do I have in mind? Multidimensional tools. So normally, usually, we would like to operate and we would like to work with the data in the multidimensional space, which is relevant for a given project. So if we take the data and we do the projection of the data and projections of some reference data, it will not help us. So we have to have the way how we compare the unbinned data or group by data for data itself in respect to the reference, where the reference could be the Monte Carlo over data versus a reference run, so assuming some symmetries. So, and after projections, it's impossible. So, therefore, we developed the tool. And what tool it is? So, when we started, we say that oversimplification at the analysis level can lead to the complex or incorrect explanations. So our objective was to have the tools where we can fit and visualize n-dimensional functions. We can validate assumptions interactively in the multi-dimensions. We can create functional compositions, which provides us rapid feedback within the seconds, not within the weeks between two meetings, but I would like to get the feedback within the seconds. And I would like to optimize the parameter space, again, with the rapid feedback time. I would like to have the configurable visualizations, so which we can manage both unbinned and binned data with interactive multidimensional history timings or some other aggregate functions, both on the servers and on the client. And as it was happening quite during the COVID time, then we started to focus in the time on the standalone client applications. So we wanted to deliver the analysis which can be provided as the standalone HTML document, eliminating the need for the additional software installations, which is perfect for the sharing within the collaboration. Okay, so what I was saying, we would like to work in the multi-dimensions, and we would like to simplify the data normalizations, data minus model, Monte Carlo minus data symmetries. So RMS spread is much smaller in case we are working with the data normalized to the other data. And what we usually provide, we provide we provide the functionality. Sorry. We provide many alternative models, and we defined the symmetries, and we are working with that on the daily basis. So here is one of the first examples which we created 3 years ago. So this was the optimizations, multidimensional parameters optimizations for the digital signal processing, which I was mentioning at the beginning. So in this particular case, we were working with the certain parameters in the examples, and we make the parameter scans. Okay, we generated over 200,000 parameters. Then we did some group by statistics, and then we provided some overview. And then, so what I want to say is that with such functionality within the meetings, we provided summary, we provided the results, and then within the discussions, we were arguing, and in case somebody had the questions like they had before, then with such dashboards, we could answer these questions very quickly, and we can address also the questions which are rising spontaneously. Okay, you can find out the detailed presentations and also the record from these presentations in the links here below. What I was saying before, I was saying what I was saying before, so that we are using the RootInteractive not only for the visualizations and navigations over the data, but we are using the machine learning techniques. And there are several ways how we are using it. So either we are using the external models, and this is quite often the case when we are working when we are comparing some models. For example, for space point distortions, we had some ideas so that we will construct the calibrations using the unit. Then we optimize global cost functions, but we wanted to know, is it working everywhere? Is it biased in some places? So we wanted to get access to this data differentially and do slicing, make the diffs and things like that. Alternative, okay, we can have usually for the simple use cases, I'm using some random forest because it's easy to optimize. And then in that case, I add the predictions unbeen predict to our data source, or different versions of the unbeen predict under the different circumstances I add to my data source, and then the following data aggregation is then done in the RootInteractive on the client, or using the standard Python tools. In addition, we made some extensions of wrappers to the scikit-learn to fast approximation of the functions and local PDFs, including the uncertainties. So this is very important because we are not happy only with the one. So we need not only the values, we want to have also the local error estimate, not global error estimate, but local error estimate, which is very important in our expert analysis of the data. In addition to that, we also provide some aggregated information for the further post-aggregation. So this is also something what we are doing with this machine learning method. And we started to implement general kernel linear regressions on the client, but this is not yet finished. But we have the first implementations. Hopefully we will finish it soon. And then in the to-do list, we have the web assembler with ONNX. I will have one slide for that. So what do I mean when I say machine learning for the derived variable? So here is example. So here we show the TPC noise map. So this is our detector. It has some noise maps. It has some gain maps. It has some occupancy. It has some currents going through each individual paths, or digital current or analog currents. And we would like to compare to see if the data are like expected. And as the detector is symmetric, then we are quite often using some assumption about the symmetries. Either assume phi symmetric, and you see that we have 18 sectors, so it should be phi symmetric, and then we can create automatic alarms to pay attention if something is deviating from this symmetry. Okay, so with the RootInteractive project, what is important is the data flow. So how I say it, so usually it consists of the two steps. We prepare the data, and then we analyze the data. So it means that we prepare the data sources, we prepare the machine learning models or different version of the models, we prepare the different symmetries, possible alarms. In some cases, we do some pre-aggregations. In some cases, we are working directly with the only with the unbeen data, but quite often we are doing also some pre-aggregations as the expectation values. And once we prepare it, we analyze it, then we came to the meetings, and then we present the summary. But and then within the discussions, we quite often open these notebooks, and we can argue, and we can defend our approach, saying that this is what we got, and we are very comfortable with the results. In case we are not comfortable with the results, quite often we are adding the new variables, and then we iterate. But quite many times, one iterations or two iterations are sufficient. So it speeds up the expert data preparations quite a lot. So how this interactive dashboards or analysis is working. So we have to define some list or array of the functions, dictionary of functions, dictionary of the variables, parameters array, so which controls the for example, selections, functions, some parameters of the and the histograms, relations between the different functions, and widget descriptions, widget layout dictionary, histogram array, figure array, and figure layout dictionary. It's so it's a list of dictionary with the relations, but it's quite big if you want to do some complex project. But usually we start with from some template and then we modify the template. I will show you two examples. What is important is the functional compositions. So we define the functions on the client, and there are several ways to define the function of the client, either using this predefined parametric JavaScript functions as it's shown here, for example, to define the bit mask if the digital currency is fine, or we can define it using the anonymous functions as defined here. So we here in this histogram we defined the variable x in variable 1 in the histogram will be variable y divided variable var normalized, whatever it means. Then we can define it using the selections like here, or using the custom JavaScript function, so which we can specify interactively during the dashboard session. So if we don't have it, if we didn't know what to do, then we can still define it in the interactive session. Another things here is the histogram declarations. So here you can see histogram declarations which we use for the calibration QA browser for the TPC. So here we defined the 2D, 3D histograms, and then we have some anonymous functions which controls the granularity, called the input variables for these histograms. And here's the example. In the lower part is the data as they are. For example, in this particular case, it's the charge, and here is the charge normalized to the random forest expectations as we selected in the controls below. So in general, we defined several templates which you can find in the RootInteractive. So for the different use cases, usually once we define the template, we define the template where we compare the data with the reference data and with the weighting or without weighting. So this is our standard approach. So there is some ongoing development. One ongoing development is to integrate the WebAssembly because current implementation is JavaScript only, and to speed it up and to have the most predictable time, we would like to move to WebAssembly for the fast Fourier transform, convolution, and deconvolutions, and mostly for the ONNX interface, because we would like to find to have the models and the derivative of the models in respect to the delta of some parameters, for example, discrepancies between model calculations and Monte Carlo and the actual data. Additional things what we are working on is domain-specific language to be able to navigate over our data, tracks, collisions, V0 cascades via indices, and to handle with the ambiguous matches between the track collisions, V0s, cascades, and collisions. And the same things for the calibration query data. So this is in a work in progress. So I would like to come with the conclusions after the demo. So as I have only 8 minutes, then I think that I will not start for the demo. I will not start I will not run it fully. I will use the expanded version because I think that we don't have time for that. So here's a tutorial for the interactive data aggregations using the RootInteractive Bokeh template. What I was saying is, by default, when in the Alice, when we are using this RootInteractive tool, depending on the problems which we try to solve, we are interactively working with the between 0 and half of the gigabytes of the compressed data in our applications. And in order to get as much data to the client as possible, we are using the lossy and lossless data compression. And this lossy and lossless data compressions, it's not only in the HTML, but also we apply this compressions also in the memory. So in the memory, we cache only the columns which are needed for a moment. Because of that, depending on the precisions which we require, the amount of the columns could go from the 20 to 200. So in the typical machine learning applications, we have plenty of the attributes and plenty of the modes which we would like to compare. Maybe with the on and x interface for the numerical derivative, we will reduce it. But for the moment, we have plenty of the rows and plenty of the columns. Okay, so here in this demo, I showed the first we import the libraries, then we generate a random columnar data. So okay, uniform distributions. As we don't have enough space in this SSL, we use only 40,000. But as I said, we are working with the 10 to the 6, 10 to the 7 data sets. We defined not only the variable ABCD, EFG, we defined also the categorical data, and we defined some metadata describing this data, which are then used for the data annotation. As I was saying before, we provide the variable list. So in this particular case, I just dump the list from the data frame, and we add there also some derived data which are lazy evaluated on the client. And then this we provide as the input, and we generate the templated dictionaries. And later we extend these templated dictionaries because in this particular case, we are adding the new user-defined functions for the multi-selection bit mask, which you will see in the demo. Then templates don't know about how we want to control our data, so therefore here we specified that we have some widgets for the variables ABCD for the ranges, some multi-selects for these categories, and multi-select bit mask for this bit mask, which we defined by this functions, which is lazy evaluated on the client. And then we defined which variables will be shown in the first glance. So with that, this generates the alias array and widget parameters. So here you can see that in addition to what we added, there are plenty of the predefined variables which are needed in order to make some infrastructures and to make some other types controlling parameters of the visualizations, controlling the relations between the histograms, the histogram ranges, histogram variables, and things like that. So here you can see that we have the set of the histograms. The histograms, it means it generates group by statistics in the bin. So we can specify which statistics do we extract in this group by, and what is the relations. So with these histograms, we create from one data source, we create the additional data source, and then we can correlate these data sources so we can make the joins between these data sources, which enable us to make some non-trivial configuration. The similar things is for the figure array. So here we describe so that what variables do we want to show and what projections, which variables from this group by data sources, from this histogram data sources, we would like to visualize.
So, Mary, you probably want to reserve some time for questions.
Okay, so the last thing. So here, once we did it, this is the template, and okay, I think I should start it earlier. So here you can see the dashboard. So with the 2D histograms, respectively with the 3D histograms. And here you can see okay, there's something going wrong, but okay.
Perhaps maybe we should at this point open the floor to questions from the audience. So does anybody have questions about RootInteractive? I want to give everybody in the audience a chance first. No? Okay, if not, well, so I have a question, which is WebAssembly. So I find that very interesting because I think that WebAssembly and Jupyter Lite is going to be a great way to for training and tutorials where you want people to have access to some software without the difficulty of downloading things. But RootInteractive, it has some dependencies that can't be WASM. Is that correct? I'm wondering if you're imagining a two-part system where the WebAssembly part works with JavaScript and works with Jupyter Lite to make the plots, and there's another part that runs not in the browser but runs on some large computational facility or something. Is that how you're imagining it?
So how I imagine it, so I mean, now RootInteractive, we have the two parts in the RootInteractive, which is the server part and then the client side.
Yeah,
so,
okay. Right.
I could imagine that we will split it, and then this client side, client part will be standalone project. So currently, this client side project, we wrote the JavaScript codes, and we have dependencies only on Bokeh.
Yeah.
So we have only Bokeh dependency, and then everything else we wrote ourselves. So now what we would like to do, we would like to speed it up, this JavaScript part. So it means that replace it with the WebAssembler. This is the idea.
Mm-hmm. Okay, so you're approaching WebAssembly as a way to accelerate JavaScript.
Yes, and also it's much easier to write with the WebAssembler, I think, and take some libraries.
Mm-hmm. Right, right. Because there are some things that are already compiled for it, such as NumPy, pandas, and that sort of thing. But something like roots it would be hard to imagine how that could ever be compiled to WebAssembly.
Okay, so we are just starting. So I think that I plan to participate in the workshop at the end of August, so we can discuss it.
Okay.
So I still don't have a clear idea. What is clear is that we would like to speed up and we would like to import the new functionality there.
Mm-hmm. Okay.
But we would like to keep the functionality which we have until now, because we are very happy with that, and I didn't see it in the other similar project within the app.
Mm-hmm. Okay. Other questions? Anyone else want to ask about RootInteractive? In particular about how you could use RootInteractive in your own analyses. on experiments other than ALICE, other than these?
So I'm not aware. So Edwin, I was not contacted by anybody from the other experiments.
Oh, sure, but I'm asking the audience here if they think they could use RootInteractive. Any questions? Well, right. Well, that's all right because we should be moving on at this point now. Thank you, Marion.